friends. So today we are gonna learn about the factors affecting the rate of a chemical reaction. In the last lecture I had told you I just given you the names of the factors which affect the rate of chemical reaction, but today in today's lecture we'll be learning all the 5 to 6 topics in brief, and so let us begin. So our today's very first topic would be the nature of the reactant. So the nature of the reactant, it is the first factor which affects the rate of the chemical reaction. So let us see the reaction of metals aluminium and zinc with dilute hydrochloric acid. On reaction of both aluminium and zinc with dilute hydrochloric acid, H2 gas is liberated, and water soluble salts of these metals are formed. However, the reaction of aluminium metal takes place faster as compared to zinc metal. The nature of the metal is responsible for the difference. Aluminium is more reactive than zinc. We all know that. Therefore, the rate of the reaction of aluminium with hydrochloric acid is higher than that of zinc. Nature of reactivity of reactants influences the rate of chemical reaction. Means the nature of the reactants is highly important when we are learning the factors affecting the rate of chemical reaction, as it also can decide the time that would be taken for the reactant or the reaction to take place. Now our second topic would be size of the particles of reactants. Now here we are given some substitutes that are apparatus, chemicals, etc., and we have to perform a chemical reaction. Now from this chemical reaction, not now but when you will do it in your 10th practicals, you will get to know that we have more effervescence. When CO2 is formed, more effervescence is formed slowly with the pieces of Shabbat tiles. You will see Shabbat tile, it is really very nice to touch while at faster speed with the powder. Means when we react CO2 with the Shabbat tile, we get that effervescence is formed. Effervescence, you know na, when you open the for the first time when you open the cap of the Pepsi or Thumbs Up, the sound which you get to hear is only known as effervescence. So the above observation indicates that the rate of reaction depends upon the size of the particles of the reactants taking part in the reaction. Smaller size of the reactant particles, higher is the rate of reaction. Means if the size of the reactant is more, means it's a bit bigger, then the reaction will take time to take place. But in the same place, if the size of the reactant is very small, then the same reaction will take place within a minute time. Okay, now we'll learn the third one. Now the third one which we'll learn is the concentration of the reactants, that how well is the concentration between the reactant and the product. Now let us consider the reaction of dilute and concentrated hydrochloric acid. Now you saw dilute and concentrated hydrochloric acid with calcium carbonate powder, that is CaCO3 powder. Now dilute hydrochloric acid reacts slowly with calcium carbonate, and thereby calcium carbonate disappears slowly and carbon dioxide also liberates slowly. On the other hand, the reaction with the concentrated hydrochloric acid takes place rapidly and calcium carbonate disappears fast. Now here what they want to tell us is that when normal dilute hydrochloric acid is reacted with the same CaCO3, this whole, when the normal dilute hydrochloric acid is reacted with the CaCO3, the CaCO3 disappeared very slowly and carbon dioxide also was liberated very slowly. But on the other hand, when the reaction of the concentrated hydrochloric acid took place with calcium carbonate, it took place very rapidly and calcium carbonate also disappeared fast. Now concentrated acid reacts faster than dilute acid, which means that rate of reaction is proportional to the concentration of the reactants. Means if the concentration is more, then the reaction would be fast. If the concentration is less, then the reaction would be slow. Now the fourth one which we'll learn will be the temperature of the reaction, or at which specific temperature should the reaction take place. Now let us see So now what does temperature of reaction say? Temperature of reaction says that while studying decomposition reaction, you have carried out decomposition of limestone. In this activity, the lime water does not turn milky before heating the limestone because of the zero rate of reaction. Now from this it is learned that the rate of reaction increases on increasing the temperature. Now I would like to speak with you a bit about this. Now what they did was that they carried out the decomposition of limestone. Means lime water does not turn milky before heating the limestone. Means in lime water limestone was put in, but it was not turning milky. Why? The process of reaction of limestone and lime water was very slow. It would take almost 1 to 2 days for the whole reaction to take place or the lime water to turn milky. But when we heated the lime water, it started reacting very fast, and hence the lime water turned milky much before the predicted time. Now let us move forward and learn the fifth one. So now fifth one is the last and the most important one, which is the catalyst. Now on heating potassium chloride, first I'll show you this example and then I'll speak to you about this. On heating potassium chloride KClO3, it decomposes slowly. You can see this reaction. The rate of the above reaction neither increases by reducing the particle size nor by increasing the reaction temperature. However, KClO3 decomposes rapidly in the presence of manganese dioxide to liberate oxygen. No chemical change takes place in MnO2 in this reaction. Now this manganese dioxide is what? Nothing but catalyst. See, when all of the properties don't work which increase the rate of reaction, we will have to use catalyst, and catalyst is fully proven it will definitely increase the speed of your reaction. Now what here happened, that when we heated potassium chlorate, it decomposed very slowly. It took large amount of time, and when we increased or decreased the particle size, then also same was happening, and same happened when we put in or increased the temperature also. But when we included manganese dioxide in our reaction, then the reaction magically speeded up. Not magically, but due to the presence of manganese dioxide, it speeded up, because manganese dioxide is nothing but a catalyst. This catalyst speeded up the speed of the reaction, and no chemical change also took place during this reaction. Now the substance in whose presence the rate of chemical reaction changes without causing any chemical change to it is called a catalyst. Hope you understood. Now friends, that is it for today. Today we learnt about the factors which can help us to increase the temperature, increase the rate of reaction, and in that we learned the 5 types which were very necessary. So friends, hope you liked the video. Do share with your family and friends, and also subscribe to our channel. You can also put in your questions down below in the comment box so that we can help you out with your problems. And friends, that is it for today. Hope you liked the video. Thanks for watching, and bye bye.